All right, what's up, guys and everybody? We're going to go ahead and get started, I guess. Got a lot of good content for you, hopefully. So this is Adopting Prometheus the Hard Way, a computer talk that I made for you. My name is Tim Simmons. I'm an engineer on the Observability team at DigitalOcean. My primary job at DO is caring about metrics and for basically all of our internal and external products. My team runs centralized logging, metrics, tracing and exceptions infra for all of DO. You can follow me on Twitter if you want. I wouldn't recommend it though, because that's kind of the general stuff you're gonna get. So a few goals that I have for this talk. I want you to walk away with an understanding of what Prometheus is if you don't have that already. I want you to understand the value of a healthy observability culture, again, if you don't already. How Prometheus and friends can help you achieve that, and maybe some of the nuances of scaling Prometheus and its adoption. So really quick, kind of blazing through an intro on Prometheus. If you don't kind of know, it's a time series database, which means it stores lots of series of time series data. That's just data points that have a value and a time at which they were observed, often called samples. Prometheus provides a very rich query language for this time series data, so you can do a lot of kind of cool stuff at, applying mathematical functions to data and that kind of thing. Metrics in Prometheus have labels, so this allows you to define different dimensions for a metric, and then you can filter, manipulate, and kind of aggregate data based on those dimensions. Prometheus is primarily used for gathering machine and application metrics, so you can imagine how this might be useful if you have a web app, for example, and you wanted to have, I don't know, page view counters for each controller or something like that. Metrics in Prometheus are collected using HTTP polls from endpoints that are actually exposed by applications, sometimes called exporters. So poll-based metrics are kind of good because it simplifies the kind of metrics process for instrumentation at your application. Basically, you are incrementing counters and doing these kinds of things directly in your code, and then somewhere you open this port, and then Prometheus goes and finds it. You don't end up with kind of complicated pipelines where pushing metrics to a central source, those metrics might get dropped or mangled or, I don't know, any number of terrible things. Because of this kind of standard format, metrics exporters exist for basically everything. So if you're running a lot of open source infrastructure, you can kind of get metrics for all of your things for free with, or at least with very little effort. And then creating metrics for your applications that are custom is possible with all the language clients that exist. There's also a lot of other very cool features in Prometheus that I'll probably go into at some point, but there's just like a cool dope slide. So the first kind of major problem, why are we all here? Probably not like cosmically, but like actually in this room. Like we're here because oh man, I hate talking like this, but we're all here to create business value. And there's a couple of ways that you can kind of do this, but one, you can be on the side of creating new features that attract new customers and delight existing ones, or you can be on the side of being an investment in the stability and improvement on the value that attracted those customers in the first place. Maintenance is less exciting, I guess. It's not so visible, it's not so new and important, but I think it's actually kind of more important than doing the new thing, because, well, you can't keep doing new things if your old stuff kind of breaks and dies. Like it's just a very important kind of thing for people to do. You can make it a lot more exciting by calling it revenue protection, which is a cool tweet I saw like 2 days ago. And I think successful revenue protection means that you can measure the performance of your system, debug it when that performance is poor, and support the customers of that system, whether they're paying customers or not, right? It doesn't matter if you have some sort of internal system, you're probably transitively supporting external customers. And observability tools are literally built for this thing, right? The idea is to kind of keep the lights on long enough so that people can see to build the next kind of big thing, I guess. A great way to encourage revenue protection is by having a healthy observability culture, and this is roughly what I think that looks like. I think you should always know kind of what's going on. I'm going to go through kind of a few outcomes of what this kind of attitude and philosophy, hopefully brings, so that we can understand how that manifests itself. So hey, dashboards are good. Big surprise here. In an incident, like clarity is kind of awesome. Being able to see what's wrong on one page, hopefully, and have a faster diagnosis and resolution loop means happier customers, happier leaders, less kind of revenue loss. And dashboards mean that more people can kind of understand the situation because it can be visualized. Leaders and support teams can have that understanding of when something is working better if they saw where it was broken on a dashboard. It's also just a really good way to make new engineers productive members of a team. A good dashboard can kind of help you visualize an architecture and the flow of data through a complex system. And diagnosing issues, again, for a new engineer, seeing big bad thing on a dashboard means like, okay, I can kind of understand this. And that's really cool and powerful, right? Because holding the architecture and debugging skills in the heads of senior engineers really kind of sucks. You can take your dashboards to the next level by adding things like annotations and explanations on the graphs and what they mean, and linking to kind of the next step in the process, be it like some docs or playbooks. Because people are really good at pattern recognition, so you can see on a graph where something might look kind of odd. Thank your lizard brain, I guess. And enabling that next step means that you kind of proliferate that information about what these graphs really mean, and that's really powerful. Now it's time for a recurring segment in this talk called Friends of Prometheus. We'll talk about Grafana because it's really good and helps you create beautiful dashboards, and arranging them is a dream. And doing things like arranging graphs in web interfaces usually is bad, but in Grafana it's not, so thanks Grafana. The Prometheus data source plugin is really, really good. There's a lot of just really other cool features, and overall I think it's the best kind of single pane of glass for all of your observability tools, because it's not just Prometheus. If you're not Grafana, you definitely should be. Hey, did you know there's a lot of value in knowing when things are broken? Duh, like this is another just real obvious hot take coming out here, but detecting and alerting on failures reliably, I think it's actually harder than you think. Alerting tools often try to exercise kind of bad admin interfaces and tools to introspect state, and then maybe tie those things together. Prometheus exporters can kind of unify all of these sources of information. You can push the bad admin tool poking down to some well-defined exporter that does that thing and exports the best kind of metrics that you can get out of there. And because alerts are just PromQL queries, they're really easy to kind of define and tweak once you do have those metrics. As an engineering team, you can save your sleep schedules by having good alerts with playbooks. So a good alert kind of only fires when something is actually broken, and then it is actionable, meaning something can actually be done to fix this. And then hopefully it has some context about what is actually happening, what is broken, what this alert firing means. Oh, customers are in pain. The website isn't loading if your RPC service in this long chain of whatever is actually having a sad day. And that kind of great alert with a playbook that enables you to know what's going on and fix it lets you hand off the pager between more people, which gets more people up to speed on a system, which is always good. And enable to you can put your manager on call, which is great because hopefully they will give you the time you need to fix something if they get paged at 3 o'clock in the morning. Having ubiquitous alerts inside an organization means that you can kind of build a hive mind around solving larger issues. So if 8 teams' alerts all go off at once, and the common thing is whatever, that can kind of help you get to a root cause faster. Another awesome friend of Prometheus is Alert Manager. So Alert Manager is a separate application that often runs kind of in tandem with Prometheus. The way that Prometheus does alerts is it evaluates those queries that are alerts on a cadence. And then when they kind of have something alertable, they send those alerts to Alert Manager. Alert Manager can deduplicate alerts from many Prometheus instances, evaluating the same alerts, and then group them together and make sure to send one good kind of notification to Slack or PagerDuty or email or whatever. Alert Manager also has a high availability mode, which is really nice because you can send alerts from many Prometheus instances to many different alert managers and only ever get one notification. And if you have some sort of outage where your only thing that is alerting goes down, that's not a problem if you have many of them, so you won't miss any alerts. This is kind of critical in a major incident because if you've lost a data center and all of your alerting is there, you might not know until you get a really angry phone call. just in general, kind of developing software with an observability culture in mind, some really cool stuff ends up happening. So with experience, you will end up building kind of better systems that are easier to revenue protect because you're visualizing how supporting and debugging that system will look like because of kind of what you've known in the past. You'll end up with clearer code because you're going to make it obvious where those critical measurements end up happening. So metrics can kind of be a shortcut to say like, oh, this is where the important thing happens. Done well, you can kind of quantify your customer experience in those numbers. So that means you can kind of make that your primary focus. Once you do that, you'll be able to evaluate how your products and teams are performing against SLOs and error budgets because you ended up measuring the right things in the first place. And that means you can make data-driven decisions about what to work on next. If you aren't meeting your SLOs, maybe you should focus on meeting those before you do new feature work. And then of course, this is the constant struggle, right? But balancing new features versus maintenance can be done, that decision can be a little bit easier if you can actually quantify your arguments. So now you have a kind of a framework for what Prometheus is and hopefully the ethos of what we're trying to achieve. I want to talk about what it's looked like for us at DO. If you don't know, DO is a cloud company like the big ones, but not quite as big, but it's still very good. Also, I have a bunch of t-shirts up here, so maybe come get a t-shirt after the talk. Like this one, it's this one. So I want to tell some general stories about how we're using Prometheus that I think are useful and kind of demonstrate what I'm on about here. So we deploy Node Exporter on every machine to gather physical resource metrics. This is stuff like CPU, memory, disk, all the basics. We scrape this on all of our hypervisors at a regional level. This kind of dashboard shows how a hypervisor is performing. This is the kind of thing that gets embedded in a lot of different support tools. Being able to alert on certain conditions of this kind of thing is really cool. So, if a hypervisor is running out of memory or we have identified some situation that means a crash is imminent, we can kind of alert on that before it actually happens. As a support or security person, having this data available to drive automation and build tools on top of is really, really powerful. Just like having this data in general to track fleet-wide patterns and answer questions like what was the 95th percentile of bandwidth, it helps make data-driven decisions and not just kind of do things based on hunches. We also keep a lot of metrics about every droplet or VM that runs at DO. This is tremendously useful for our support teams. There are a lot of ways to get this type of information when you are running a cloud company and you need to know a customer has a support inquiry about their VM, but this is kind of the thing that is reached for first a lot of the time. Another one that's kind of embedded in support tools. The way we do this is we wrote a custom exporter that exports these metrics on each hypervisor for all the droplets that are on the HV, and we scrape that again regionally. This data actually powers a number of really powerful tools that it's not an exaggeration to say we've used that data to help solve problems that were costing a company millions of dollars a year, right? This is critically important data that is used a lot. We have a centralized kind of bus of in-flight or completed events at DO, and these are kind of the events of VMs being created or destroyed, backups happening, stuff like that. This is a visualization of the events that are currently in flight or completed or failed, and how long they've been running or how long they took. This is powered by Prometheus histograms from a custom exporter that I wrote, and of course Grafana. Huge shouts to Grafana for literally the sexiest visualization you will see today. Luckily, we're the only cloud company out there that never has incidents, but let me tell you, that top graph in an incident, boy howdy, let me tell you, it gets red and angry when something theoretically would ever be going on. When somebody senses kind of a disturbance in the force maybe, being able to look at overview graphs like this, that's like one panel, this is kind of the state of our world is really powerful and cool. Also, it's so pretty. All right, our internal service level management project is also extremely good. Most products can define being healthy in terms of a Prometheus query. So what we do is we run Airflow jobs that query that Prometheus on a cadence and then persist these key SLIs to HDFS because Prometheus only keeps about 15 or 30 days. This means we can query these key performance indicators going back forever. And that's really cool. So the first thing that we did this for was with droplets. We again wrote a custom exporter to detect when droplets were having downtime due to hypervisor issues. So now we have this kind of thing in place where we can calculate SLOs over time and see that we're actually tracking and improving. We have this for products all over our business now, and it's really, really cool. It's kind of just a good North Star to orient yourself towards, to make sure that you're constantly tracking that you're improving customer experience. Our scheduler team has written an exporter to give metrics on the capacity to place different types of VMs in our hypervisor fleet. So having this data from the view of the actual scheduler means we are as close as we could possibly be to the real state of the world. Bugs that exist in the scheduler will result in these graphs. So even if, the capacity, physical capacity folks are saying there is capacity there, it's like, well, sorry, bud. There's something wrong with the schedulers. And that's really, really powerful. Being able to alert on this stuff in real time and sense trends and say, oh, wow, we're heading for disaster can be really, really good. I want to point out that that's 4 stories in a row where we have gotten this kind of uncommon level of insight into a system by writing a custom exporter. These were all kind of highly, tailored solutions to our architecture and software. There was no off-the-shelf solution that would have given us this type of insight. You would have had to have done some custom instrumentation. And I think this is one of the coolest things about Prometheus, because none of these things took more than a couple of weeks to actually achieve, but they kind of give us that perfect thing that it's like, I wish I could know that about my system, and it's literally there, it's on a graph, and it's useful. So this is the slide with the numbers on it. I don't know how productive this actually is, but I think it could be a good starting place for conversations. So I guess if you want to do that, come talk to me. For example, if you want to know why samples per second is so low compared to the other things, or if you want to come tell me about how a single big server could scrape that many samples, yeah, let's come up here and fight me, I guess. Or talk to me after this. I don't care. Let's just chat, it's fine. So I want to give you some tips on scaling Prometheus from an operational perspective. There's just a couple of things that I think you need to know, because I really don't think this is, it's not an easy problem, but this is not operating Kubernetes, for example, here. This is a much more kind of helpful, friendly system from that perspective. But that said, this is the slide. If you're going to take a picture of my slides with your iPad or something, this is the time to do it. This is really important. So when you're creating metrics for an application in Prometheus, remember that each unique permutation of labels creates a new time series. So when you eventually query those metrics, you need to know that if your query needs to process thousands or tens of thousands of time series to complete, you're probably going to have a bad time. It's important to point out, again, this is not samples like the data points in a time series, but this is the number of different time series you're actually accessing samples in. So this isn't just a graph with 1,000 lines on it, which is probably not useful anyway. Say you have a metric with a user ID label in your system, and you want to know how many users have that metric greater than n, or you want to know some sort of quantile of what the metric is for all of your users. Prometheus has to operate over every single user to do the calculation of whether they're greater than n, for example. So in general, labels that have cardinality, that means the number of possible values, more than a few thousand is probably a bad idea. I'd like to acknowledge this kind of sucks because a lot of the time there's some really cool information that you could get, per user metrics, for example, in your system if you could do something like this. But it's just straight up not what Prometheus was meant to do. However, you can get away with this depending on what you're doing. You just kind of need to understand the limitations, understand how the thing is going to be queried, and you can actually do some cool stuff. Because of this kind of limitation, you're going to hear people say that metrics are a dead end from an investigative standpoint. Don't listen. It's fine. You might not be able to go find the specific container ID that was having a problem, but you can probably find the pod. And if not that, then you can find the application, and then you can go find the container. It's fine. It's fine. This isn't, at Google, yes. There is no way to do cardinality like this, and they've invented crazy systems. For most people, you shouldn't have to worry about this too much unless you do something that has cardinality in millions. The easiest way to figure out if your query is going to be terrible before you actually do it is to do it in the console view in Prometheus. So in the Prometheus UI, there's a graph and a console view. The console evaluates your query at one point in time, the latest point in time. So if your query takes 10 seconds to evaluate at one point in time, Graphing it over an hour where it has to be evaluated 100 times to make a pretty graph means bad things are going to happen. If it takes 10 seconds, then it's going to take a lot more time going back. Prometheus probably needs some extra RAM, especially if you're using kind of custom metrics where cardinality might be an issue. During normal operations, it's actually pretty chill about general resource usage, and even under moderate to high query loads. But then someone will do a query that uses 50,000 time series over 7 days, and stuff like this can happen. So this server was running happily for days at 6.5 gigs of memory usage, and then quickly, instantly, essentially ran out of memory at 16 gigs. I see stuff like that, like this happen fairly often. But you know what? RAM is cheap, and Prometheus is actually pretty good at restarting after it runs out of memory. So just something to keep in mind. It's fine. I don't know. Have another one. So eventually there will be a set of metrics that you want to query that's going to get really big, like too big for a single instance. You probably don't want to have more than a few million time series on a single Prometheus instance, again, unless you know kind of what you're after. You'll want to stand up more Prometheus and shard the metrics collection. So you should always be sure to shard based on something that is kind of a logical query boundary, something like a region or a service. You don't want to split up scraping by taking some hosts' metrics in one instance and some hosts in another, because querying across multiple Prometheus instances is kind of a pain, and it's sort of non-trivial. You can do it, and getting that global query view is possible, but there is rarely a situation where I think it's super necessary. Again, you can do it though, it's fine. For metrics that you really care about, which is hopefully all of them, you should deploy HA pairs of Prometheus instances. So this is multiple Prometheus that scrape the same metrics, preferably in different geographic locations, to isolate yourself from those kind of failures. This is cool because then you can use Nginx or HA proxy to sit in front of those instances and do things like load balancing queries or doing an active-passive type of situation. You can also do things like rate limiting and log your queries if you want. And that's really helpful, especially to catch query criminals who are doing something wrong. When you do catch those criminals, it's probably going to be because there's some metric that is kind of causing your system pain. Go read this blog post, and then you'll know how to find them, and I guess tell the people to stop. So scaling Prometheus by itself from an operational perspective, honestly, I think is kind of the easier bit. It's well written, it works really, really well. Getting people to adopt it and use it to its fullest potential from an organizational perspective is a lot harder, in my opinion. I think this is the good part, so if you're asleep, wake up or something. Remember how I talked about why we observe our systems in the first place earlier? It's about revenue protection, which is how you add value if you're not adding new features. So if you want to provide maximum value, which gets you maximum paid, you should build observability into your systems. There's a problem with that, though, because basically no matter what happens, you are going to be doing that under some sort of pressure. You can do it in the beginning, under pressure to get back to building more new features, or you can do it when something is broken and you'll have to spend extra time retrofitting it in later, possibly into an architecture that wasn't really built well for that type of thing. Either way, you're going to have a limited amount of time to spend building observability into your systems. So engineers do what engineers do. They copy the patterns that they see. And these patterns end up proliferating through organizations because everybody is short on time, right? So that means the impact of a good or a bad pattern actually gets multiplied out over time by a fair amount. And with Prometheus, more so than something like logging or tracing, you are doing custom instrumentation. So this is kind of a real issue. You are deciding what kind of metrics to create in your code. You are actually incrementing those things in your code. So the quality of your outcomes and your data is much more dependent on the decisions that you make, rather than something organizational, like hopefully tracing is kind of integrated into your whole system. And this can kind of bite you because at first, everything is fun and easy. Like you installed an exporter, you created a couple of metrics without reading the docs, and you're like, oh dunk, like I can see inside my app now, the world, your galaxy brain. But doing things like actually measuring your availability and quantifying your customer experience is a little bit harder if you didn't follow best practices when you were creating your metrics, or maybe you don't understand some of the theory. Standing up that Prometheus server and then scraping those metrics is super easy too. It's like, well, you pull down the binary, you edit the YAML file, you start it, it's great. And honestly, for a long time, it's going to be totally good. But then you might have a lot of metrics or a time series leak, or you might want to start sending alerts and make Grafana dashboards. Then all of a sudden, you're operating 3 different applications, and your ability to alert on failure and measure the performance of your system, these critical efforts are built on that playground that you stood up a year ago and haven't touched. This can get worse, though, because if you were the first person to do this, and then everybody in your company copied you doing that, now everybody has a crappy playground that is literally in the critical path of revenue protection. And that's bad. When you go on to kind of define alerts that make on-call good or try to create those good dashboards, if you don't have patterns that are easy to follow, maybe because you can't find those other teams' Grafana instances that they stood up because they're down or hidden somewhere, that's going to be bad. And then eventually you're going to start writing queries that don't come back. And that could be for a lot of different reasons. And you're going to have to go and either figure out why, which is taking some of that limited time, or just give up, throw your towel in and forget it. What I'm saying is that each of these steps, the choices that you make, impact the next, and they all build on each other. Every decision actually matters, and they are multipliers on your ability to effectively maintain the system in the end. When you're short on time, making those good decisions is actually hard. So this is why I think that you need people dedicated to this problem. And this is what I mean by adopting Prometheus the hard way. That's the air getting let out of the balloon of my sexy talk title, because it's obvious. The naive path, I don't want to scare you off. The naive path will get you a lot of value with your pain. But I think the hard way is kind of where the real magic happens. I think you can multiply your gains by 100 times by establishing good patterns and iterating on them over time and making sure that people are kind of protecting that value. So what are these people actually going to do? It's important that everybody kind of make good use of their limited observability time, obviously. Everybody needs to have a basic understanding of how to use those tools. The tools need to be operated well so that they are actually available and scalable so that people can keep getting that value out of them. There needs to be patterns and documentation in a centralized place that people can go and copy if they need to. And somebody needs to be around to consult with teams while they are kind of have that 1 week or 2 weeks to actually start making their stuff observable. Eventually, that kind of momentum in an organization can sustain itself when everybody is kind of seeing what it looks like to have your stuff be easy to maintain. And once everyone wants to be on that train, this is the kind of thing that is desirable, at least. So what I mean by operating Prometheus and friends, it should go without saying, but you shouldn't stand up tools without somebody to be responsible for them. Eventually they'll rot, they'll become less useful, they'll break completely. When it's something like alerting when your systems are down or being able to debug your system in an incident, that is not acceptable. Keeping teams from standing up bespoke installations of Prometheus, Alert Manager, and Grafana, and more, and not caring for them is important because that is a perfect waste of that limited time that I keep talking about. You could be instrumenting applications rather than breathing life into a fragile observability tool. Somebody needs to be on call for that Prometheus and friends, and that gets more complicated as you make that stuff highly available, right? Like you shouldn't have all of your dashboards in one Kubernetes cluster in one data center, because then if that Kubernetes cluster goes down, not only can anybody see graphs about their own applications, they can't see graphs about the Kubernetes cluster. So you're kind of really in a bad situation. Making sure that everybody's metrics and alerts stay healthy is also really cool. So over time, metrics themselves actually end up rotting. They stop being as useful, or they just kind of disappear because applications move, and alerts are based on metrics that changed at some point, and the alert is still off trying to fire like, hey bud, I'm doing my best, but you changed metrics, so I don't know anything anymore. Having somebody that keeps an eye on that stuff is really valuable, because you can kind of prop up and maintain that value that somebody made when they had that limited time. They also need to decide when it's time for more Prometheus and be able to justify that expense. If somebody's adding a bunch more metrics and that is too much for the current system to handle, it's important that somebody can say like, okay, it's going to cost this much are these metrics that you made worth this much money? It's a good thing to know. It needs to be easy to copy those good patterns. Again, I'm driving it home, but having some sort of config file in Chef or Ansible, or a Docker image with that config file and source control where everybody can play with it and kind of add to it self-service is a really good first step. Eventually this ends up getting too big. Nobody wants to edit a 20,000 line config file. You need to then provide some sort of abstraction. Let people declare that they want their metrics scraped rather than making it happen themselves. But it's important when you do this kind of abstraction that you don't obfuscate the core concepts. Still try to enforce some basic level of understanding of the system, because ultimately it will become a black box, and people will do mean things to the black box. Or worse, if they don't understand the black box, then it can disincentivize them from kind of owning their own availability, and they won't use the box. This is kind of a hard problem, so if you come up with something cool, I guess let me know, because I would like to know. You need to be able to point people at a place where they can learn about what they should be measuring. They should go read the golden signals chapter in the SRE book or use the use method or something like that. Helping them be able to quantify that user experience is good stuff. You should, as a person doing this, create common metrics patterns for things like RPC apps and Kubernetes apps and things that are similar, so that you can apply general purpose alerts and general purpose dashboards to make it easy for everybody to kind of understand all of the systems that share these characteristics. Make them go read Cindy's blog post about how to do alerts right. That's the thing. And you'll need to document all your other various internal tools. So having contextual Prometheus query examples for systems that people are probably familiar with, explaining how Alert Manager works so that people set up alerts that kind of fit well into that flow. And however you end up getting people's metrics scraped, you should kind of document that so that people can hopefully self-service that. The other big part is consulting with teams when they're adopting this tool. So when a new team starts, they're going to have a lot of questions and need a lot of help. Having someone there to kind of answer those questions saves people time from beating their head against a wall. And for highly expensive and smart engineers, that opportunity cost is real, because whatever they could have been doing is probably really valuable. When the tools become semi-ubiquitous in an organization, people will start reaching for it to do more and more things. So there will be more and more of a need for people to kind of help with more advanced queries, alerts, explain why Prometheus ended up doing this thing. This is probably like a third of my job now, is kind of helping people do this kind of stuff. Being able to suggest advanced concepts like recording rules or relabels when somebody has a problem is really good, because basically if they haven't done it before, there's no way they're going to know to reach for that, and they might end up doing something that takes much more time. Again, losing time. And because my team ends up knowing where a lot of the kind of the metrics and the observability data are, we're able to kind of jump into incidents and help track things down, just because we kind of know where things are in the tools. And we can also kind of help with a lot of other kind of important cross-functional efforts. So stuff like standardizing operational readiness review criteria and implementing error budgets is something that these people can kind of be the owners of. So these are kind of some of the problems that I had set out to solve when I kind of started doing this kind of thing. We had things that needed to be discovered in Chef, and Prometheus didn't support Chef, so I wanted to do that. I wanted to kind of centralize alerts, basically do these things to centralize knowledge, centralize configuration so that people can copy the stuff. My attempt was to, what I did was create a Git repository that acted as a configuration directory for some code that turned these YAML abstractions into Prometheus configuration. My team reviews pull requests to this repository and provides feedback on what people are doing Prometheus-wise. So checking that their metrics are good, checking that their alerts will or won't fire, stuff like that. This is kind of a double-edged sword, because what ends up happening is that people do have better metrics and better observability, but it's not completely self-service. So if you have kind of limited time and you see that you're going to have to wait for somebody on that team to review things, then you might choose to do something else instead. I also wrote a lot of documentation that most of the time people don't read because they would rather just ask the question directly. But overall, I think this is still important because it enables the best type of folks to actually go and learn. And it's important to have kind of a centralized short version of this stuff that you constantly shove in people's faces so that hopefully they get those basics. If I did it over again, I would probably build on top of the Kubernetes Prometheus operator. I think there's a lot of potential in having some sort of application on top of the operator that kind of verifies that metrics are good and places them somewhere and verifies lots of other resources and then actually creates necessary Kubernetes CRDs to make that stuff happen. But I don't know, maybe someone from the audience can come up and tell me if that's a bad idea. So that's what I think you need. I think that you need people to kind of do these things. I think this function fits naturally into a team of people that do this for other tools also. Having this kind of influence for centralized logging, tracing exceptions, I think is extremely valuable. And I don't think you need to hire any sort of observability expert for this type of stuff. So what happens in the end? You've done all of this work. What is the result? Some people will really love it. They'll get involved. They'll build tools. They'll build tools on top of Prometheus, which is always really cool. Most people will just copy pasta the stuff they see. They'll get a couple alerts, get a couple of dashboards. Fine. That's totally cool, right? Because they have got value in that limited time. Some people want to push beyond. This could be an entire talk in itself, but what people will want to do is stuff that can sometimes be solved by some of the other kind of newer friends of Prometheus out there. And again, all of these use various different approaches to do some combination of downsampling, long-term storage, global query views, and better handling large cardinality. But the thing that you should keep in mind is that any of these things are going to be a lot more work operationally than good old Prometheus. So that's all I got. Come get a shirt, come ask me questions. I'm not going to do questions in this crazy big room. So that's it. Thanks.